Okay, so for number 2, we've got a weight hanging from a spring, and it's stretched down 5 units beyond its rest position and released at time 0 to bob up and down. So its position at any time t is 5 cosine of t. So they want us to find the velocity and the acceleration at any time t. So the velocity is just the derivative of the distance. So v of t equals, and finding this derivative, we get minus, because the derivative of cosine of t is minus sine t, minus 5 sine t. Now the acceleration is just the derivative of the velocity. So the acceleration with respect to t equals, and the derivative of sine t is cosine of t, so we get minus 5 cosine of t. And that takes care of it. Well, here we go with problem 3. And so we have to find the derivative of tan x with respect to x, but we want to write it in terms of sine x over cosine. Let's get that. Cosine of x, and which is tan x. And so now we'll use the quotient rule, and this is 3, by the way. And the derivative, oh yes, we square the denominator, cosine of x, so we square that. Then we hold cosine of x constant, and we take the derivative of the numerator, sine of x. Well, that is cosine of x, the derivative is, of sine of x is. And then minus, and now we'll hold sine of x constant, and take the derivative of cosine of x, which is minus sine of x. And so what we have is cosine squared of x, minus times a minus, that'll be a plus sine squared of x, over cosine squared of x. Well, that numerator, that's just 1. Cosine squared of x plus sine squared of x is 1 over cosine squared of x, and that equals secant squared of x. So in other words, the derivative of the tangent of x, and we knew that, with respect to x equals secant squared of x. Well, now we're going to do number 4, and we're going to find the second derivative of the secant of x. Well, we better find the first derivative initially, and so we know from our table that the derivative of secant of x is secant x tan x, that product. So y double prime equals, now we're going to have to use the product rule. So we'll hold secant of x constant and take the derivative of tan x, which is secant squared x, plus, now we'll hold tan x constant and take the derivative of secant of x, which is secant x tan x. And let's simplify that, so it looks like we have a secant cubed of x plus secant x, and we have 2 factors of tan x, so that's going to be tan squared of x, and we've got it. Good. Well, finally, we can do question 5, and we can evaluate directly here, because if we let x go to 0, the secant of 0 is 1. And so 2 plus 1 is 3, so we get square root of 3. Now downstairs, tan of 0, letting x be 0, is 0. And so we just get the cosine of pi, and the cosine of pi is -1, so that equals negative root 3. And we've done it. We're good. Well, we have one more to do. And here it is. We need to find the limit as theta goes to 2 pi over 3 of this quotient. And this quotient is related to this statement, definition of the derivative. In this case, instead of dealing with x, in fact, in this case, x equals theta. And f of x equals f of theta. And a equals 2 pi over 3, and f of 2 pi over 3, f of a, is root 3 over 2. So what we have here, what we're given, the limit as theta goes to 2 pi over 3 of the sine of theta minus root 3 over 2 over, all over, theta minus 2 pi over 3. That just equates to the derivative of the sine of theta with respect to theta, evaluated at theta equals 2 pi over 3. Well, the derivative of the sine of theta is negative, not negative, beg your pardon, is the cosine of theta, and we are evaluating that at theta equals 2 pi over 3, which equals cosine of 2 pi over 3. But 2 pi over 3 is in the second quadrant, and the reference angle pi over 3, the cosine of pi over 3 is 1/2, so this, since it's in the second quadrant, cosine of 2 pi over 3 is going to be -1/2. And we've got it.